the mid-segment theorem is what we're talking about today, and it's to find unknown measurements in a triangle. The mid-segment theorem is a segment that goes through the triangle to where it bisects both sides. So it means it cuts both sides into two equal parts. Okay, so that has to be true for the mid-segment theorem to work, and to know that this line in the middle of this triangle here is the mid-segment itself. So the mid-segment theorem is more like an equation as well, and it states that the mid-segment, which I'm just going to abbreviate as M, is equal to half of the base. And that's it. It's just half of whatever the length of that base is. So if you need to write this down, please pause this video now. Otherwise, I'm going to move down to the examples. Okay, so example number 1, as you see here, it directly talks about, or actually shows us that we've got these congruent marks here to say, hey, it's bisecting both sides. That means this guy in the middle has to be our mid-segment. Okay, and you can just call it M, but I'm writing that out for right now. And we know that that mid-segment, that 19 plus X, is supposed to be equal to half of that base. So this guy is the base. It's the longest side there that we're concerned about. It's parallel with that mid-segment. So half of that base, which is X plus 31. Okay? So I've set up my equation, and from here, it's just algebra. Now, you could choose to distribute that 1/2, but honestly, it's more work than it's worth. Just kind of think about, what can I do to get rid of dividing by 2? Well, the opposite of dividing by 2 is multiplying by 2. So it's easier if I just go ahead and choose to multiply by 2 on both sides. However, whenever I do something on one side and I have to do it to the other, it applies to the entirety of this entire side here. So I need to put this in parentheses, so I make sure to apply that 2 to both the 19 and the X. So after that, we're just going to distribute it. 2 times 19 is the first thing we're going to do, which is 38, I believe, off the top of my head. I'm going to double check it real quick with the calculator. Yes, 38. And then 2 times X is 2X. And then since I canceled out that 1/2, I'm only left with X plus 31 on this side. After that, it's pretty simple algebra that I know you guys are pretty comfortable with. Get all the X's together. 2X minus X is 1X. Okay? So we've got 38 plus X equals 31. Get rid of that 38. And you will get that X is -7. And that is our answer. A negative is just fine, because if I plugged it back in and checked, so if I checked it, 19 minus 7 is what that would end up being, is 12. And -7 plus 31 is going to be 24. So 12 and 24, 12 is half of 24, so we know that we did the right thing. The theorem holds true here. So if you need more time to write all this down, pause this video now. Otherwise, I'm going to move on to the second example below. Okay. So, same scenario here. Whenever we set this up, we know that this guy's going to be our mid-segment, and we know this mid-segment theorem holds true because it's saying, hey, this is bisecting both sides. And that makes my other remaining piece my base. So, I set it up the same way I did above. I take my mid-segment, 2X minus 6, and it equals half of my base, which is just 2X. Now, for this one, you can choose to do the same thing we did above, where you multiply by 2 on both sides to get rid of that 1/2. However, if you're noticing here, you're just doing 1/2 of 2X. So basically, 1/2 of 2. Or the same as 1/2 times 2, which is just 1. Or in this case, 1X, if we're doing half of 2X. So you could go ahead and see that, hey, those are going to cancel. And do that instead of doing all that work we did above. I'm fine if you do it that way that we did above, but that's just working smarter instead of harder. Okay? So from here, we're going to move the 2X over to the plain 1X. So X minus 2X is a negative X. Okay? And we can get rid of that -1 by dividing it over. And I'm going to be left with X is equal to 6. If you did it the other way like I did above, which like I said, you can still do, it doesn't matter. If you would have done that, you would have multiplied 2 over here and had to distribute that 2 to both pieces to where you would have gotten 4x minus 12. Okay, so you would have 4x minus 12 equals 2x and would have arrived at a similar answer and at this exact same x. So it would have looked similar through the steps, but still should have arrived at x equals 6. If you need more time to copy this down, pause this video now. I'm going to move on to example number 3. Alright, example number 3. Same scenario. We see both sides are being bisected. So midsegment theorem works, and this has to be our midsegment. And that means the other guy has to be my base. So we take our midsegment, x minus 2, set it equal to 1/2 times my base, which is x plus 8. Now on this one, oops, can't see that. On this one I would do what I did on the first example, get rid of that 2. But what I do to one side, I have to do to the entirety of the other. Okay? So now I'm going to distribute that 2 to the x, so 2 times x is 2x. And do it with that negative 2 as well. 2 times negative 2 is negative 4. And then I'm left with x plus 8 on the other side. So simple algebra from here, get the x's together. So 2x minus x is 1x. And get the constants together. So move that 4 over, and you're going to get that x is 12. And again, if you wanted to think through this, 12 plus 8 is 20. 12 minus 2 is 10. 10 is half of 20. Okay? So if you need more time to copy this down, pause this video now. Also, for number 4, I would highly recommend pausing this video before I work through it and see if you can work through it on your own. So I'll give you a second to do that. So on this one, same case scenario, both sides are being bisected. So that means this guy right here has to be our midsegment, and the other one is our base. Set it up the same way we've been doing. So take your midsegment, x plus 16, set it equal to half of my base, which is x plus 25. Okay? Do the same thing we've been doing. Get rid of that 1/2 by multiplying by 2 on both sides. But what I do to one side, I have to do to the entirety of the other. So now, just distribute from there. 2 times x is 2x. 2 times 16 is 32. And then I'm left with x plus 25 on the other side. Again, very simple algebra from here. Get your x's together. 2x minus 1x is x. And get your constants together. So move over that 32. And then 25 minus 32, gotta punch it in to check it, is negative 7. So x equals negative 7 on that one. If you need more time to copy this down, please pause the video now. Otherwise, I'm going to move to the back page. Alright, so we've got 2 examples left. Here I would highly recommend, again, pausing before I work through these because I'm going to talk a little bit faster, but they're the same exact thing. You will see on your practice, and I'll talk about this here on these examples, but on your practice, you will get asked something like, tell me the measurement of DC. So I'm going to add that in here on number 5 to find the actual measurement of DC. So if you want to try to attempt that on your own first, go ahead. You can pause this video now, and then you can check your work when I've gone through it in the next little bit. So again, both sides are being bisected. So that means this guy's my midsegment, this guy's my base. So I'm taking my midsegment, x plus 4, setting it equal to 1/2 of my base, 4x minus 4. We're going to do the same thing I've been doing, multiply both sides by 2. But what I do to one side, I have to do to the entirety of the other. So put parentheses. And then distribute that 2 to both pieces. So 2 times x is 2x, 2 times 4 is 8. And I'm left with 4x minus 4 on the other side. So same thing we've been doing. Get all the x's together. And I'm going to be left with 2x. Get all the constants together. And I'm going to be left with 12 over here. So I should get that my value of x is 6. Now, like I said, you will see some examples on the practice where they ask you, hey, find the actual measurement of some length. And it'll usually either be the midsegment itself, so DC is the midsegment, or it may be the base. Doesn't matter which one. All that means is look for which piece you're concerned about. So DC, its expression is x plus 4. Okay? If they wanted the base, that would be 4x minus 4. So they want the actual measurement. Well, we know what x is, right? X is 6. So now we need to plug in 6 in place of x, and that'll tell me the measurement of DC, which we've kind of already talked about on the front page when trying to check and see if we're doing it right. So 6 plus 4 is 10. So you will see something like that on the practice. Don't be scared of it. You're just plugging x back in. All right, let's talk about number 6. So on this guy, same scenario, bisected on both sides. That means this guy's my midsegment, the other guy's my base. Take my midsegment, 2x plus 31, set it equal to half of my base, x plus 26. Then I'm going to multiply both sides by that 2 to get rid of it. But what I do to one side, I have to do to the entirety of the other. So then I just distribute from there. 2 times 2x is 4x. 2 times 31 is 62. I'm left with x plus 26 on the other side. Get the x's together. 4x minus 1x is 3x. Get the constants together. 26 minus 62, I'll need to punch that in super quick, is negative 36. Get rid of that 3, and you're going to be left with x is negative 12. So, at this time, I'm finished working through the notes. So, if you are done with this, go get the practice from the sub and start working on that. If you have any questions, please feel free to message me through Remind. And if you are still not on Remind, it's at Brandel G. Okay? So, please feel free to message me with any questions that you have on this. So, hope you guys have a good weekend, and I'll see you all on Monday.